Okay, in this video, we're going to be doing Calc BC Problem Set number 34. The problems and a playlist are in the description below. Let's take a look. Number 1, we want to find the interval of convergence for the power series shown above, which is the sum from 1 to infinity, 5 to the n, quantity 2x minus 1 to the n over 2n plus 3 squared. What I like to do is I don't like to have 2x minus 1 to the n, so I'm going to rewrite this thing so that I just have like x minus something to the n, which means I'm going to factor a 2 out of everything in 2x minus 1, and then have 2 to the n, and then x minus 1 half to the n. So let's see what that ends up looking like. We're still going to have this part. So I said I'm factoring a 2 to the n out. Well, I mean, I'm factoring 2 out of 2x minus 1, but it's to the nth power. So 2 to the n. I'm left with x minus 1 half after I factor the 2 out, and then that is raised to the n. And then we're still just over quantity 2n plus 3 squared. Now we're going to do the ratio test because we're looking for interval of convergence. So that's going to be the limit as n approaches infinity of the absolute value of the n plus first term. So we just take every n and replace it with n plus 1. So we're going to get a 5 to the n plus 1, 2 to the n plus 1, an x minus 1 half to the n plus 1, and then 2 times n plus 1 is 2n plus 2, and then plus 3, so 2n plus 5 squared, times the reciprocal of the nth term. So I'm just going to pop that up there. That's the reciprocal of the nth term. Now we have to take the limit. What happens on these is a lot of things cancel out. So if we look at the 5 to the n plus 1 and the 5 to the n, that's going to cancel a 5 to the n. We're just left with 5. Similarly here with 2 to the n plus 1 and 2 to the n, we'll be left with 2, so 5 times 2. When we look at our x minus 1 half to the n plus 1, x minus 1 half to the n, we're left with x minus 1 half to the first, but it's in an absolute value, and x is the only thing here that could be negative, so we have to leave the absolute value. So absolute value of x minus 1 half. And then we look at the polynomial part. What happens with the ratio test is the polynomial parts, like the n plus first version and the nth version, they're always just going to have a limit of 1, so they kind of don't really contribute. So we're done with the limit. We just need this thing to be less than 1, because we know we'll converge absolutely on that interval. So I'm going to divide both sides by 10 to get the absolute value of x minus 1 half is less than 1/10. I'm going to draw a number line here, put 1 half in the middle, and I can go 1/10 in either direction. So 1/10, 1/10, which takes me to 11/10 on this side and 9/10 on the 11/20 and 9/20, I should say. So we converge absolutely on this interval. What we need to do is determine the endpoints because the ratio test is inconclusive. So what we'll do is we'll say, let x equal 9 over 20, go to the original series and plug in 9 over 20 for x and see what we get. So when we do that, we'll have 5 to the n. I'm going back to the original series, not the one that I factored. I don't know why I chose that, but I did. So we have 2 times 9/20 is 9/10 minus 1 is negative 1/10 to the n. And then just over that denominator. And then if we look at this, we can simplify this a little bit because both things are being raised to the n, so we can make it 5 to the n times negative 1/10 to the n is negative 5 over 10 to the n, or negative 1 to the n over 2 to the n. So I'm going to choose to write it that way, negative 1 to the n over 2 to the n. It'll look like this. This converges by the alternating series test. I don't really think you need to show the work on that because it's not really the point of the problem, but it's alternating, the terms decrease in magnitude, and they have a limit of 0, so it converges by alternating series test. So we know it converges there. We have to do the same thing at 11 over 20. So if we do this, it's like the exact same thing, basically, except instead of negative 1/10, you get positive 1/10, which means that we get this 1 over 2 to the n, quantity 2n plus 3 squared. This converges by either direct comparison to 1 over 2 to the n or 1 over n squared. Doesn't matter which one you choose. I chose 1 over n squared. So we get it converges at both of the endpoints, which means the interval of convergence is from 9 over 20 to 11 over 20 inclusive. So we include all the endpoints. All right, so that's, I mean, those problems are kind of a lot of work, but they're not super hard. Let's take a look at the next one. Find the perimeter of the region bounded by x equals 2, the x-axis, and f of x equals the sum from 1 to infinity, x to the n over 3 to the n minus 1 times n factorial. All right, so it's important to notice that this thing is starting at 1, what I'm going to do is I'm going to figure out what this function would be if it started at 0, because I think it's a famous function. But that's different, right? Because the given one starts at 1, and we're starting at 0 to figure this out. So if I did that, I would rewrite it as 3 to the negative first, 3 to the n, because then I can take 3 to the negative first out, which is just, 1 over 3 to the negative first. 1 over 3 to the negative first is 3 to the positive first, so just 3. 3, and then we would have our sum. We have x to the n over 3 to the n, so I'm going to make that x over 3 to the n. And then over n factorial, I see that n factorial, and I think to myself, that's e, right? That's the factorial that's with e, but remember, we're still starting at 0 here, but we're going to get 3e to the x over 3. Because we started at 0, but the actual given series is starting at 1, what we have to do is figure out what happens when n equals 0 and subtract that term off. Like, we don't want to include the 0th term. We want to start at the first term. So just take n equals 0 and plug it in and see what you get. You're just going to get 3 times 1. So you get 3, which means that the series starting at 1 is the thing that we found, 3e to the x over 3, and then minus that first term, so just minus 3. So that's our f of x. Now it becomes kind of a normal problem, so instead of like typing it all in, I'm just going to show the screenshots. This is what happened when I graphed that function to just get a sense of what's going on. So we're looking for the perimeter of the region bounded by x equals 2, the x-axis, and f of x. All right, so that's this part, which is going to be 2 along the horizontal, right? Because you're going from 0 to x equals 2. Then from the horizontal up to the function is just going to be f of 2. And then we're going to have the actual arc length, which requires the calculus part. So what I'm going to do is I'm going to write this down. So our perimeter will be 2. So the number one thing I see people forget here is the horizontal and the vertical distance, or one of those two. So we need the horizontal, we need the vertical, then we need arc length. Arc length is going to be the integral. So this is arc length of a function. So it's the integral from 0 to 2, square root of 1 plus f prime squared, and then dx. So what I did was I just punched it into the calculator. You can see an image of that here, and so I'm going to write down what we got. So I got approximately 8.333. All right, let's take a look at the next question. Find the value of the maximum possible error in using the first 4 terms of the series shown to approximate the sum of the series, and then we want to justify. So if a problem doesn't explicitly state that you should be using the Lagrange error bound, or the problem doesn't explicitly tell you what to use for m, you should be thinking this is probably alternating. If you look at this, this is definitively an alternating series because of the -1 to the n. So I'm going to write down that this converges. You want to cover that because otherwise you're not really allowed to use the alternating series test. So this has terms that alternate for sure. They definitely decrease in magnitude because 5 over 6 to the n just keeps getting smaller, and then you have an n plus 1 squared. You could also like make it a function, take a derivative. I think that's overkill on this problem because it pretty obviously, I think, decreases in magnitude. And then they definitely have a limit of 0. That means this thing converges. All right, so once it converges, we know that the error is at most the first term that we leave off. So if we're using 4 terms, that's n equals 1, 2, 3, 4. So our error will be the absolute value of what we get when we plug in 5. So I'm going to plug in 5. So the error in approximating our sum is less than, plugging in 5, it's the magnitude of that term. So absolute value, -5 to the 5th over 6 to the 5th times 6 to the second, I guess. That's a bad looking 2, but that's definitely to the second, which is, to explain it, just the magnitude of the first term that we left off. Alternating series error is pretty straightforward. I would say it's, of the 2 types that you know, it's by far the easiest to find because it's literally, did you use 15 terms? Then the 16th term will be the error, the absolute value of that term. All right, let's take a look at the next one. Given f of 6 is -5, f of 7 is 1, and the integral from 7 to 6, which is, I don't know, I look at that and I think that's wrong. You shouldn't write it that way. The integral from 7 to 6 is 12. Find the integral from 6 to 7 of x, f prime of x dx. So this is pretty clearly, in my mind, integration by parts. I'm going to take care of immediately the fact that this is just written wrong, right? So the integral from 6 to 7 of f of x dx will be the opposite of the integral from 7 to 6. So if 7 to 6 gives you 12, 6 to 7 gives you negative 12. Good stuff. All right, let's rewrite this thing. So I'm going to color code it. I'm going to use u is equal to x because taking derivatives of that is easy. dv is f prime of x dx because I can take a derivative of that. It's not going to help me because I don't know any values of f double prime. So I basically have to choose that for our dv. So we have this. I'm going to take the derivative of u, which is just dx. I'm going to find the antiderivative of f prime, which is just f. And then integration by parts is going to be uv and then minus the integral of v du. This could be problematic if we didn't know the integral of f of x dx, right? Like we're given that in the problem. If we weren't given that, then this would not be the right approach, or just we would get some weird answer with an integral in it. Sometimes that happens. So we're going to use fundamental theorem on this. So integral from 6 to 7 of x f prime of x dx is going to be x f of x evaluated from 6 to 7, fundamental theorem, minus the integral from 6 to 7 of f of x dx. At this point, it's kind of just plugging in. So we get 7 f of 7, and then minus 6 f of 6, minus the value of that integral. The value of that integral is negative 12. So if you look up top, f of 7 is 1, f of 6 is negative 5, so we have 7 times 1 minus 6 times negative 5, and then it'll be plus 12, so 7 plus 30 plus 12, which I think is 49. Okay, so that's the entire problem set. I hope this was helpful, and good luck.